Welcome back to All This Math. This is Professor Parker. If you're here, hit the like button. Also hit the subscribe button if you haven't subscribed already. If you have any questions about anything I try to explain, please put your questions in the comment section and also share this video with at least two people, all right, two parents that may have children in elementary school, or grandparents, or aunties and uncles that might have, nieces and nephews that's in elementary school and want to be able to help them with their homework. All right, so what we're doing today is we're adding two-digit numbers using number bonds. We're adding two-digit numbers using number bonds. All right, this is helpful because it's going to prepare young children for later when they're in a chemistry class, doing work in chemistry, dealing with chemical bonds. Also, it's preparing them for using the distributive property, how they're going to decompose or break numbers down so they can do mental math using multiplication or addition with large numbers. All right, that's just two benefits. All right, so now, how do we do this? So we got two add-ins. We got 27 and we got 13, right? Now, we want to break one of these numbers down. We want to pick one of these numbers. It don't matter which one, but we want to break one of these numbers down. And, we want to have one of the numbers that we break it down into is going to end in 0. So what I might do is this. I might take this 13, right? And I might change it to 10 plus 3 because I know 10 plus 3 is equivalent to 13, right? Now, how does that help me? What's the point of doing that? Right? What's the point? The point is it's easy to add 10 to any number. It's easy to add 10 to any number. So it's easy to add 27 plus 10 because what we're doing is we're only changing the number of groups of 10. So 27 has two groups of 10 and 7 ones. But if I'm adding 10, I'm not worried about the ones. I'm only worried about the groups of 10. So 10 is one group of 10. And that plus 20 is going to give me 30. So then I have 30 with 7 ones, right? 37. All right, that's going to give me 37. So let's do that. Let's do 27 plus 10, which is 37. So we write 37 down. Then we write a plus sign. Why? Because we still got this 3. We still got to worry about this 3, right? We're not done. Now, 37 plus 3. Now, think about it, right? What if now I could count on, I could use the counting on method, right? Start at 37 and go up by 3. I could go 38, 39, 40. That's 3 fingers, right? So that means the answer is going to be 40. That's one way to get to the answer. Another way to get to the answer is to think about it like this. I could then create another number bond, right? Well, I break this down into 30 and 7, right? Now, why would I do that? Because I know that 3 plus 7 is equal to 10. And that's something that's a fact. That's an addition fact that our children should have memorized. If they're adding two-digit numbers or expected to add two-digit numbers, they should already have the addition facts with one-digit numbers already memorized, knowing that 3 plus 7 equals 10 from memory, knowing that 7 plus 3 equals 10 from memory. Now, if they still have to draw the circles or draw the boxes or draw the lines, draw 7 lines and then draw 3 lines and then count them all up, that's fine for now. But we want to have the goal. Our goal is for them to have that just memorized. Like 7 plus 3 is 10. 3 plus 7 is 10. Just know, but also know why, but also just know it. All right. So now 7 plus 3 is 10. So that's going to give us 30 plus 10. Again, where does 30 come from? Came from right there, right? Where does 10 come from? Came from doing 3 plus 7. Came from doing 3 plus 7. Or think about the commutative property. The commutative property says that the order of the numbers won't affect the result. 3 plus 7 is equivalent to 7 plus 3 because their sum is still 10, regardless. So then we got 30 plus 10. 30 plus 10, we got 3 groups of 10 and 1 group of 10. 3 groups of 10 and 1 group of 10. 3 groups of 10 and 1 group of 10. Altogether, that's 4 groups of 10, which is equal to 40. Right? So 20 means that 27 plus 13 is equal to 40. It also means that 37 plus 3 is equal to 40, which also means that 30 plus 10 is equal to 40. So that also tells us that, and this is an introduction to what we call the transitive property of mathematics. 27 plus 13 is equivalent to 37 plus 3 is also equivalent to 30 plus 10 because they're all equal to 40. They're all equal to 40. So that means they're all equal to each other. These are what we call equivalent expressions. Equivalent expressions. Equivalent expressions. All right. So hit the like button. Subscribe if you didn't subscribe already. Like I told you before, please share this video with at least 2 people. Put it in your group chat. All right. And if you still got questions, that's cool. I want the questions. Bring all the questions, right? Type your questions in the comment section. All right. And I will see y'all later.